Welcome back to Space Repo, your portal to the cosmos. Today, we're asking a question that has baffled scientists and philosophers for centuries. What happened before the Big Bang? If the Big Bang was the very beginning of time, space, and everything we know, then asking what came before it seems like a paradox. It's like asking what's north of the North Pole. But human curiosity knows no bounds. We can't help but wonder if our universe's grand opening was just another event in a much larger, more ancient story. The standard model of cosmology tells us that about 13.8 billion years ago, the entire observable universe was compressed into an infinitesimally small, hot, and dense point called a singularity. Then, in a fraction of a second, it expanded rapidly, an event we call the Big Bang. This expansion created space, time, and all the matter and energy that would eventually form galaxies, stars, and planets. But the laws of physics as we know them break down at the singularity, leaving a gaping hole in our understanding. So, what do our most brilliant minds think might have filled that void? Let's explore some of the most mind-bending theories. One of the most compelling ideas is known as the Big Bounce. This theory suggests that our universe is caught in an endless cycle of expansion and contraction. Imagine our universe expanding for trillions of years, just as it is now. Eventually, the force of gravity could overcome the expansion, pulling everything back together in a big crunch. All the galaxies, stars, and matter would rush towards each other, collapsing back into a super-dense singularity, resetting the cosmic clock. But instead of being an end, this crunch would be a new beginning. The incredible pressure and energy of the Big Crunch would trigger another Big Bang, giving birth to a new universe from the ashes of the old one. In this model, our Big Bang wasn't a singular creation event, but just one bounce in an eternal series. This cyclic cosmology elegantly solves the problem of a beginning. There was no beginning, and there will be no end, just an infinite dance of creation and destruction. This idea is part of a broader concept called cyclic cosmology. Different models propose various mechanisms for these cycles. One version, called the ekpyrotic model, comes from string theory. It suggests our universe is a three-dimensional brane floating in a higher dimensional space. Occasionally, our brane might collide with another parallel brane. This cosmic collision would release an enormous amount of energy, heating our universe and triggering the expansion we identify as the Big Bang. After the collision, the branes would drift apart, cool down, and then, drawn by parent universe, a concept rooted in the idea of a multiverse. This theory, known as eternal inflation, was proposed by physicist Alan Guth. It suggests that the rapid expansion phase of the early universe, or inflation, didn't stop everywhere at the same time. Instead, while inflation stopped in our cosmic neighborhood, allowing our universe to form, it continues in other, more distant regions of space. These eternally inflating regions are like a cosmic foam, constantly spawning new bubble universes. Each bubble universe could have its own unique set of physical laws and constants. Our Big Bang would simply be the moment our particular bubble nucleated and began to expand. So, before our Big Bang, there was this vast, inflating metaverse or multiverse, a chaotic sea of energy from which countless universes are born. We are just one island in an infinite cosmic ocean. This idea is both humbling and awe-inspiring. It means our universe, in all its vastness, might be an insignificant speck in a much grander reality. But let's push the boundaries even further. What if before the Big Bang, there was nothing? This might sound simple, but in the realm of quantum physics, nothing is far from empty. Quantum mechanics tells us that even a perfect vacuum, stripped of all matter and energy, is not truly empty. It's a seething cauldron of virtual particles that pop in and out of existence for fleeting moments. This is known as quantum foam or vacuum energy. This nothing is fundamentally unstable. It's a state of pure potential, waiting for something to happen. According to some theorists, our entire universe could be the result of a random quantum fluctuation in this primordial nothingness. A spontaneous energy fluctuation could have created a tiny, dense universe out of the void. Once this seed of a universe appeared, the process of inflation would have taken over, stretching it from a subatomic size to a cosmic scale in an instant. This is the ultimate something from nothing scenario. In this view, the question "what caused the Big Bang?" has a startling answer: nothing did. It was a spontaneous, uncaused event, a statistical possibility in the quantum realm that just happened to occur. This aligns with the principle that the total energy of the universe is zero. The positive energy of matter and radiation is perfectly balanced by the negative energy of gravity, so no net energy was needed to create the universe. These theories, the Big Bounce, the multiverse, and creation from nothing, are at the very edge of our scientific understanding. They are based on complex mathematics and theoretical physics that are yet to be proven. We currently have no way to directly observe what came before the Big Bang. The cosmic microwave background radiation, the afterglow of the Big Bang, acts as a barrier, hiding anything that might have preceded it. However, scientists are actively searching for indirect evidence. For example, some cyclic models predict specific patterns or anomalies in the cosmic microwave background. Finding such a pattern could be a tantalizing clue that our universe had a past. Similarly, future advances in gravitational wave astronomy might allow us to detect echoes from a pre-Big Bang era. The quest to understand our cosmic origins is one of the greatest adventures in human history. It pushes our technology, our mathematics, and our imagination to their absolute limits. Whether our universe is one in an infinite cycle, a bubble in a cosmic foam, or a lucky fluctuation in the void, the answer is sure to be more incredible than we can possibly imagine. The story of our universe may have started 13.8 billion years ago, but the story of existence itself might be eternal. Thank you for joining us on this mind-bending journey at Space Repo. If you enjoyed unraveling the mysteries of the cosmos, don't forget to like, subscribe, and hit that notification bell. Until next time, keep looking up.